So, okay, now I don't feel cold. Yeah, so warm up. And AI is so hard for beginners. Why? Because even this, I can show you first this source code. We can see here this source code not too long, only 300 lines blocks, right? But the question is, here the 300 line, that's just the ML code block. I mean, that's just code block here. You can see that is only a very small piece. If I give this code to you, share this code to you, can you run this? If you have background of Python software development, I believe you can run it. But if you don't have any software development background, how can you run it? Because let's put the ML code aside. We can see the traditional AI and the machine learning process. Once you write code, you need to put the code running. So you need a serving. The same concept as if you have any experience for the web development, software development. If you develop your website, you have to put your code running on web server, Apache, Tomcat, IIS, Nginx, lots of server you need to take into consideration. And once you got your code deployed, you need a monitor system to monitor your code quality, to trace. Now we got not monitor, trace, right? And for machine learning, the data is very special. Data, training, model. This concept is not included in the traditional software development. That's the machine learning, AI exclusive, I can say, for data science. So maybe it's a good opportunity to join deeplearning.ai's course, because I joined this course and I passed the 3 or 4 MLOps course. I learned a lot from Andrew and some great scientists, developers. They share a lot to me. So yeah, so okay, let's back to this demo. Write code and run code is not enough. For example, 3 lessons I learned from Squid Game, just like this short video, this short game. First one, motion detection, right? Why it can trace my finger? They use one Python library. The library name is OpenCV. You see, OpenCV. So once it got my motion detection, you know, if I failed game, it will detect my face and recognize my face. It will aim on my face, right? So here we use 2 models. One for the BG model for the motion detection, another for the face recognition. So I will not go through all these models to you here because I only have half an hour now. And you just need to know OpenCV, Squid Game, face recognition right now. And by the way, for the real TV, they use the Vertex and for the shooting, right? So that's still for the AI. Okay, so if I share this code to you, how can you run this code? For example, I run this code locally. If you want to run this code locally, you need to prepare first Python runtime, Python IDE. For example, I use VS Code here. Maybe someone use PyCharm, right? And you need to download prepare all the Python package management and the virtual environment. For example, OpenCV here, NumPy here, virtual env, Conda, and sometimes you need a different Python runtime with Python 2, Python 3, different versions, lots of jobs you need to do. And sometimes maybe GPU, container. For example, now if you want to run something, NVIDIA Docker on Windows 10, it's not easy to implement that. Why? Because you still need the WSL, because we know the Docker design and stuff for the Linux, right? You maybe you need to install another OS. So you see, for hardware, OS, runtime, package, lots of layers You need to think about, you need to design it. So you may ask me, are you kidding me? So your topic is beginner, codeless. Why you show us code? Why you show us environment? That's not for beginner. Okay, so it's time to introduce our another great platform. That's Colab from Google. Yeah. So we can see here Colab. Colab can give us the chance to use the zero configuration required, free access to GPU, easy sharing. And because they use Google Drive as the external storage service, so it's very easy to share my code, share my model, share my data by the Google Drive. That's very good. And the most important, it's free. It's free. Yeah. So let's take a look at another demo. Colab. Okay. So we will use the same. Let me reconnect. That's the OpenCV, the same OpenCV. You see CV2. But this time, we run this demo on Google Colab, and it's free. You just need to log in your Google account. So first, if someone asks me, is it really with GPU for free? That's very easy to validate. We can use the commander NVIDIA-SMI. Not bad, right? Tesla K80 with 12 GB memory for free. So good. And we can take a look which OS it used. They use Ubuntu. I believe they use Docker container to host the whole Colab environment. How can I validate that? That's very easy. Host name. See, give me the name, just like this. If you have any experience in Docker management, in container, you will find that this is the container name, right? And we can also use the commander core HTTPS to get the IP info. Yeah, you see, it gives us the address, and I believe you can search this address is the Google address. So I mean, this is a real Google environment. Okay, so let's go through the code. The same CV, but this time you don't need to prepare Python. You don't need to prepare any library. You don't need to prepare Docker container, virtual env. You just put your code to Jupyter. Then this Jupyter running on Google, running on GCP with Colab. Yeah, so I will switch my camera. So I will stop my camera here, turn off my camera, and yeah, just no. Yeah, here this time they use the face classify, use the hair cascade. I mean, this is what I used for the Squid Game code. The same, you see, the same one. And for the webcam image, let's take a look. Yeah, let me hit capture. Yeah, you see, the same face object detection, but we can run on locally and running on Google Colab as well. Yeah, let's try the live web camera videos. Yeah. Yeah, you see, that's the live web camera, used OpenCV, running on Colab, running on GCP. Yeah, so good. So the same, if you want to run this code, I can share this code to you later because it's open source. You don't need to prepare anything except Colab. Let's take a look at another fancy demos, because if you have any experience, you will know OpenCV is a very good image tool, and for the model, there is another model, advanced model. The name is YOLO, and the YOLO, the full name is You Look So Good. It's incorrect. The full name is You Live Only Once. That's George. George corrected me today afternoon. Yeah. So let's take a look at what YOLO can do. So let me see. Can I run the code directly here? Yeah, this one. And this one. Oh, I have to run off because I think they will force you. Yeah. So I mean, even Colab, it's not a perfect platform. First, because we use the free version, so I mean, it will force you timeout. I mean, you cannot handle the resource all the time. So here, maybe I need to run it again. Yeah, run again. It will import all the package and compile the package, download package. Again, it cannot handle and keep our session as long as possible. Another job back, maybe this another job, I cannot use terminal. Let's say it's Colab Pro feature. Yeah, so no freelance, right? Yeah, it's still download. I think this is the model. This is the Dark Knight is the model for the Colab for the YOLO. We can take a look. What is the darknet with the fancy name darknet? Yeah, that's the YOLO 4, and the YOLO has different versions, and that's the paper. You can see this model usually running on the GPU with this entry-level GPU. Oh, that's all the academic. Yeah, YouTube video of result. Yeah, you see even that's the YouTube video. They can not only compare with the previous, I mean the OpenCV and the face detection. This one will be better. This one not only can recognize or detect your face, it can give us more information. So let's take a look, but it's still download. I think this model is very large. Yeah, that's my fault. I should prepare it before our session. Yeah. Yeah, it's made. This is made to build this model. So far, if you have any questions, for free, let us know. So you can post to channel, or you can just open your microphone to ask us any questions. I think Mike, George, and I are so glad to answer any questions. Let's take a look. So you see, another topic for most, I mean, the AI beginners, the GPU management and the GPU, which types of GPU graphic card you want to choose to run your AI model. That's another very good topic, I mean, because we did lots of the GPU prototype and the GPU projects in Canada here. So, I mean, someone always asks me, I have video game GPU. Can I use it for machine learning? The answer is yes or no. Depends on which kind of model do you want to use it. So just for this, I mean, you can see here the entry level GPU can save you lots of time, but if you choose a good professional GPU, that will save you more and more time. That's very, very important to choose the GPU. And that's for individual. For enterprise and for the company, I mean, a very robust GPU platform, GPU cloud platform, that's what you need to consider, to think about, to design. So I published the full blog about, let me see, how to choose and how to build a robust GPU platform. You can take a look. That's my blog address. Yeah, so we made the GPU platform with the NVIDIA A100, the latest NVIDIA powerful, the most powerful machine learning graphic card in the world, I can say, on vSphere. And we passed through with A100 and A100 multiple instance group features enable and running on Kubernetes. And after that, we did some bare metal testing, Docker testing, Kubernetes testing, and I share another real multi-tenant cloud GPU consume use case. So if you had any interest, feel free to take a look my blog series. That's about the GPU platform. Okay, still comparing, yeah. Okay, so we will take look the YOLO platform after maybe I give you another platform. Yeah, we can look back. Yes, let me open my camera again. Okay, so far, I used almost 20 minutes to go through the Colab and my local dev environment, and everything is fine. So, Codeless, beginner, 2 keywords, you promise, right? Which platform is for the beginner, for Codeless, for today's topic? That's our platform. Another platform by Google, Vertex. Vertex compared with the GCP, because we know the industry, we have Google GCP, Amazon AWS, and Microsoft Azure, 3 main platforms, public platform for everything. But for the cloud, Google built another new brand, Vertex. I think the middle of this year, yeah, Vertex AI. So that's the definition from the Vertex. With the Vertex, now we got 80% fewer lines code required for custom modding. You see, it can reduce your code with 80%. That's so good. So let's take a look again. Let me switch to the Vertex. So you can see Vertex is another sub-brand under GCP. And the dashboard is very clear. You see, that's almost the life cycle for the machine learning, even deep learning, the same. I mean, start from data and the features, you need to prepare data, and you need to prepare your pipeline if you have pipeline. But pipeline is another topic for the MLOps. If you just training, running, then serving, then you don't need a pipeline. But if you need to keep training, keep inferencing, you need a pipeline. And after you training, you got your models, you will generate your endpoint, right? You will generate your endpoint. After that, you can do some batch prediction. So even if we have not started our Vertex job, from this dashboard panel, we can guess what we should do. Yeah. And yeah, let me back to still makes. Okay, so for the data sets, I prepared two different data sets. One with the 7-day image. Actually, I did yesterday, and another one with the more than 3,000 images. Let's take a look at the easy one. So for this demo, we use Vertex. First, I import 7 images with two famous actors. I prefer to use their Marvel name, Loki and Thor, right? They're brothers. And 30 Loki images and 40 Thor images. First, I import into Vertex. They are labeled with two great actors. So before I label, what should I do? I should let platform know. Even the platform here give me choice. For example, you want to do image classification for single label or multiple label or object detection or image segmentation. For this one, we just do the image classification with single label. For example, when I do the inference, I will upload the image and it will give me, this is either Loki or Thor, right? That's the single label. It will just give me yes or no, Loki or Thor. And it's wizard. Yeah, we got wizard. So create, and input your data from your local or from Google Storage. And after that, you just need to label. And after your label, you can training directly. You don't even know what the model, what the training algorithm. You just follow the guide, right? Create. With 70 images, they will give you 3 options: AutoML, AutoML-H, custom training. So here, because we don't have any background, that's for beginner. So we will not choose the custom training. We will just only use AutoML. That's the keyword we want. Codeless, AutoML. That's what we want, right? So we can see here the definition, the more, choose a train model, so blah, blah, blah. So actually, you can see they will give us the definition. So it will don't require you have any data science experience needed, right? No, AutoML is codeless. Yeah, that's what my topic, right? And for time to train model, lower, less data preparation is required, and no development is needed. That's what we want. Yeah. So after that, we can continue. We can start the training and give us the budget, because that's Google Vertex is not a free platform. It's still one component of the GCP. So we need to consider our budget first. For example, here they use the maximum node hours. So if I give 8 hours, they will start training, and I will not wait the training. I will just go to the what after training. So we will have our model. We don't even know what the model format, what model binary. We just know we have our models, right? Yeah, that's our models. And we can take a look. Yeah, so they will give us some diagrams, some charts, for example, some precision curves, some precision recall by threshold, right? This one is very important. Tell you how exactly your model precision, accuracy, and Google Vertex, during your training, they will automatically classify your image. For example, they will use most part for training, and they will reserve some images for validation and reserve some images for testing. So you see, from the wizard, you need to do nothing, but you now get your model, and with your confusion matrix, right? You will sort, predict, label, and Loki. Okay, so let's take a look. Can we run a test? Yeah, we can upload image. Yeah, we can upload very handsome actor here. Give me Loki. Oh, maybe I need to choose another one because I think the picture I choose not so good. Let me choose another maybe with large face here. Yeah, maybe this one would be better. Yeah, so more than 90, right? More than 90. Let's take a look. Choose Loki. Yeah. Yeah. Choose. Yeah. 100% make sure this guy is Loki. See, even you see, you can publish with endpoint. That's so easy. You just click, then it will create the endpoint. You choose your, for example, let me repeat it again. Once you got your model, you can deploy, because I have already deployed this model, so you just deploy to endpoint with your name and, for example, so for others, continue, and you even can specify your traffic split and the number of compute nodes here you want to choose, and with logging, yeah, then you choose deploy, you will get your endpoint like this, and you can take test by the GUI here, and also they will generate the API. Yeah, you got the API, so it's very easy for the furthermore development. So far for the Vertex, we didn't write even one line code, right? That's exactly codeless for beginner to know image classification with the automatically machine learning. So that platform, I highly recommend you can take a try, but also you need to control your budget. I mean, if you not sure, I mean, your budget constraint, just let me know. I can give you some advice. Yeah. Okay, so finally, let's go back to our Colab. I think it's finished, not. Okay, this time I think it's finished. Yeah. So let me turn off my camera here, and yeah, because I think the camera being taken by the Zoom by the team. So let me refresh it because I have already turned off the camera here. Yeah. It's already running. So I think still something wrong with my camera settings here, but I can guarantee this. I will share all this Colab address to you, and you can run this code by yourself. Yeah, that's very easy to go through all this source code here, or is still make compare the source code. Yeah. So yeah, so let's back to Vertex. You can see the Vertex, another great classification why I like Vertex is, you see here, let's go back to data sets. You can create, no matter, so if you ask me, Ken, I want to do something for tabular or for test, do you have any options? For example, the previous demos we use the most is classification for image, for face. Here, if you want to do some regression, yeah, I mean, the linear regression, that's almost the first lesson for the most machine learning course, right? For the supervised machine learning with the linear regression, with the classification. So if you want to do some linear regression here, the same, you just choose tabular. Test, right? You can do something. Video, the same. So with different data types, you can do different machine learning jobs with zero code. With you don't need to do training by yourself. You don't need to know what the model it is. So that's totally for the beginner. So now you are the winner. We have already, let's take a look. Here I used almost 35 minutes to introduce the library, Python library, OpenCV, with the face model here and the YOLO, right? With two different algorithms, classification, regression, and three platforms. The first one I run Squid Game locally with local Python shell. And after that, we switch to the Google Colab. It's free. But sorry, I cannot successfully running my second demo. Or maybe after George's session, I can go back to show you. Yeah. And the third one is Google Vertex. That's the true codeless for AI for beginner. Yeah, so that's my today's topic. Yeah, so if you have any questions, feel free to ask me. That's my blog address, and